Modern-day physics experiments can be significantly bigger and more expensive than they were in the past. In the 1600s, Newton discovered fundamental properties of light using nothing more than a dark room and a prism. And in the late 1800s, J.J. Thomson completely redefined our understanding of the atom using essentially the components of an old TV, or at least what at the time would become TVs. These days, cutting-edge research can require 27 kilometers of tunnel on the French-Swiss border. This is the Large Hadron Collider, and it is currently the biggest particle accelerator we have. The main objectives of the 9 experiments being run at the Large Hadron Collider are to discover and study the Higgs boson, to study potential candidates for dark matter, to study antimatter and look for supersymmetric particles, to look for extra dimensions, and to study the conditions of the early universe, which is believed to be a quark-gluon plasma. To do this, protons and sometimes heavy lead ions are accelerated to speeds close to the speed of light using these concentric circles underground. This is done using lots of magnets and quite a lot of engineering. 2 beams circle at the same time, one going clockwise and one going anti-clockwise, with 4 crossing points where the beams are able to be intersected. When they do and the particles collide, detectors like this track the debris, and people smarter than me do lots of maths and data analysis on the results of that to tell us things about the fundamental properties of the particles that we're observing. The Large Hadron Collider has now been running for over 15 years, and it had to be shut down for a few years in the middle of that run to have some upgrades to make it even more powerful. In that time, it has detected and confirmed the existence of the Higgs boson. It has generated quark-gluon plasma as well as lots of antimatter for us to study. It has even managed to make tetraquarks, which are particles that have 4 quarks in them, and pentaquarks, which are particles that have 5 quarks in them, both of which were thought to be impossible in our current understanding of how particle physics works. Most notably, though, is some models that have been developed to expand on the standard model have predicted particles that have not been found at the Large Hadron Collider. If I've said some words that you've not understood in this video, make sure you're liking and following along, because we're going to be talking about the standard model of particle physics next week, and those words will hopefully be explained. Thank you for doing everything that you do here, and until next time, I have been Dr. Alex Foden, the Science Wrangler, and I shall see you one of these days.